Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1171, remove zero-sum consecutive nodes from linked list. This is a medium difficulty Leetcode problem. And in this problem description, we're told that we're given a head of a linked list, and we repeatedly delete the consecutive sequences of nodes that sum to zero until there are no sequences. After doing so, we want to return the head of the final linked list. And we may return any such answer. And so we're given some examples, and we're told that these are all serializations of list nodes. So although they're represented as arrays, these are actually, we should imagine them as nodes in a linked list. So in this example, we're given a list of a linked list basically, and we have an output of 3 and 1, and that's because we are basically returning, basically like there's two answers, there's 3, 1, and there's 1, 2, and 1, and it's basically all every time we find a sum or a kind of like a chunk of our linked list, our basically consecutive sequences of a linked list, as it says here, that sum up to 0, we skip that. So in this example, we've got 1, 2, minus 3, 3, and 1. Well, we can see that this chunk over here, these consecutive linked list nodes, sum up to 0. So we just skip it. We just go straight to here, which is why 1, 2, 1 is one of the answers that we could return. So we're just skipping over the nodes which add up to 0. Well, what is the intuition behind this kind of problem? Well, the way we can solve this problem is by using a prefix sum. So if we store a prefix sum for each of our nodes, so let's say we have, I don't know, 5 minus 2, 2, yeah, 3, and we can see that these consecutive nodes here add up to 0. So we can say initially we were at a prefix sum of 5, and then we got to a prefix sum of 3, and then we got back to a prefix sum of 5. Well, if we are now back at 5 and we've already seen 5, we know that we've gone back, everything in between the last time we saw 5 has just cancelled out. It hasn't added anything, hasn't contributed anything to our linked list value. It's just cancelled each other out, which means it equals to 0. And so we can just skip. We can skip from 5 all the way to 3 and then carry on processing. And so that's the logic behind solving this problem, is we're going to have a prefix sum which stores the prefix sum and the node. And if we ever come across a value, we're going to say, we want to have two different passes. So the first pass number 1, is where we're basically going to go in and add, each node and a prefix sum. So, 1 and then the node for 1, and then 3 and then the node for where it equals 3. And then we're going to have a second pass, and the second pass is going to be where we say, okay, if we've come across you again, we're just going to remove you. So if we come across you, we're going to skip to the last occurrence of you. So we're going to skip everything in between you and the last occurrence, because everything in between the node that we are at and the last occurrence of that node is just going to sum up to 0 anyway. So I hope that intuition kind of makes sense. But yeah, let's actually get to coding this problem. So the first thing we want to do, of course, is we're going to have a dummy node. This is going to be just so that we don't override our actual node. So, this is best practice, of course. List node is 0. And then dummy is going to be equal to dummy.next. So, actually, dummy is not going to be equal to dummy.next because there's nothing to that. So it's going to be head.next. So let's say head.next. And then after that, we want to actually construct our prefix map. So we want to say prefix sum is going to be equal to, which is going to be equal to 0. And then we want a hash map as well. So we want to say, let's call our hash map scene. It's we're just gonna have a hash map now, and we're gonna say our current pointer to our dummy, and while current is not null, we're going to increment our prefix sum. So prefix sum plus equals n, no, not n, current.value. There is no n over here. And that's actually current.val, not current.value. And then what we want to do is say this prefix sum, let's set this prefix sum equals to that node that we are currently at. So this is the node, basically the node where we found the prefix sum is what we're saying we want to store. And then we're going to move on to the next node. So current is going to be equal to current.next. So this is basically our first pass, add prefix sum plus corresponding node. Now we have our scene hash map built. What we can do is do a second pass. So second pass skip over 0 some consecutive sequences. So now what we can say is let's just set current equal to dummy again. We're going to set prefix sum. Prefix sum is going to be equal to 0 again. And we're going to say while current prefix sum plus equals current.val. And then set. Now this is the part where it tricks people up. What we want to do is say current.next is going to be equal to what we last seen. So you might think, will it not just point to itself? No, it won't, because we would have already overwritten it over here. So this will store the last occurrence of this prefix sum and the node corresponding to it. So I'm going to say current.next is going to be equal to seen where we've seen. So if we haven't seen it, then it will just point to itself. Otherwise, if we have seen it, then it will skip to where we've seen it, basically. So we'll set seen is going to be equal to the prefix sum dot next, and then we're going to say current equals current dot next. So if this is not the case, if this just move is itself, then this is where we will move beyond the self node. So if this, if in the prefix sum, this node that we're currently at pointed to itself, that's fine. It won't do anything. It will just move on to the next node. Otherwise, it will skip to the last occurrence of where that prefix sum is. So I hope that makes sense, guys. What we want to do after this is just simply return dummy.next. This is going to contain our fresh linked list, which has no consecutive sequences of nodes that sum up to 0. So let's submit our code. Let's check everything works as it should. And it does not, because node is not defined. So this should actually not be equal to node, it should be equal to current. So let's set you to current. And we get a wrong answer. Okay. 3, 1. Okay. Dummy needs to be equal to head. We're skipping out this first node. Nope. That's not it. Okay. Okay, so so we're creating our dummy list node. We have dummy.next. So now we're overwriting our dummy with head, which is not what we want. Okay, now we passed all 105 test cases. So the first thing we were doing is we were setting this equal to head.next. We were skipping the first node, and then we were just removing dummy totally, and then we would just get a messed up linked list, which wouldn't be the correct linked list that we wanted. But now that's solved. In terms of time complexity for this problem, guys, it's going to be big O of n for both time and space. I hope this video made sense. I hope the problem makes sense. Understanding that we need to use a two-pass prefix sum and hash map problem can be a bit confusing, but once you understand it, it's relatively straightforward compared to a couple of the other prefix sum hash map problems out there. And obviously the linked list does add an aspect of confusion to it. You do get a couple of bugs. You really have to make sure that you've passed all edge cases, and that there are no bugs in the code that you've written. Anytime you do anything with a linked list, it can be a bit hard to spot what's going on. But I hope this video was intuitive and made sense, and I'll catch you in the next one.